Alright, we're going to now finish up the last problems here on the Math 0306 Review Concepts worksheet. We just solved our first equation in number 4. We reviewed that concept of solving equations. We're now going to do the same thing in number 5, only we have some parentheses in the problem, so we're going to have to do a couple extra steps in this one. So, the things to remember in a problem like this, number 5. When you have a parenthesis, if you have subtraction directly in front of the parenthesis with multiple terms inside, or if you have a number directly in front of the parenthesis without an operation smashed in between them, then you have to distribute that number or that negative through the following parenthesis. So the approach we can take here is the subtraction we distribute into this parenthesis, into each term. If you recall, you kind of can think of it as if you're taking a -1 and multiplying it by everything inside, which is just going to change the signs. And then here you have this -2 out in front of this parenthesis. You do want to take the sign with it when you distribute. So it's actually like we're taking a -2 and distributing it inside, multiplying it to each term inside that second parenthesis there. So first step here, we're just distributing. Okay. So when we distribute, we are left with, bring down the 6, that doesn't change. -1 times 4 gives us a -4. -1 times the m just makes that positive m a negative m, equals. Bring down the 8m. -2 times 3m gives you a -6m. -2 times 5 gives you a -10, so -10. Whenever you multiply and get negatives, you just write that as subtraction for that particular term. Alright, now this problem becomes the one we did, just like the one we did above in number 4. Combine any like terms on the same side. To clean up the problem a little bit. Well, here we have 6 minus 4. Those are both constants. We can subtract there to get 2. Then bring down the -m, because those aren't like terms. 8m and 6m, those are like terms. They're both single powers of m. 8 minus 6 gives us 2m. On that side, bring down the -10, because again, that's not a like term since it doesn't have an m on it. So now we've combined like terms as much as we can on the same side. Now we need to get our like terms that are on opposite sides together onto the same side. So we want to get our m's on the same side, our m terms. We can start, let's get rid of this -m over here. The opposite of subtracting an m would be adding an m, and that will cancel it out here. And we have to add an m on the other side of the equation to keep it balanced. Whatever we do on the one side, we have to do to the other. So this leaves us with 2 on the left equals 2m plus a single m gives us 3m, and minus the 10 as we bring that down. Now we want to get our constants together on the left hand side. To cancel out a -10, we add 10 to cancel out here. So we have to add 10 onto the other side as well. This cancels out the 10s over here. So 2 plus 10 gives us 12, equals, the 10s cancel out, all we have left is the 3m over there. So once again, this is pretty much following just the way the previous problem went. We have a coefficient attached to our variable, so to get rid of that coefficient of 3, we always divide by that exact coefficient. Divide by a +3 on both sides, and it ends up being 4 again, like the last problem. 12 divided by 3 gives us 4. The 3's divide each other out, leaving us with an m equals 4. And once again, we could check our work to make sure it is correct by plugging 4 back in for m. And you should get the same value on the left-hand side that you get on the right-hand side. I'll leave that to you guys to do to check, though. Again, in case you don't trust my work, go ahead and check it. Alright, one more type of problem to solve that you're expected to kind of know this coming into 0306, but it's pretty easy to forget some of these things. What if we throw fractions into the problem? And not just regular fractions, these are kind of rational expressions, we call these. Kind of confusing looking fractions. Fractions that have variables and numbers and multiple terms in them. Not just your basic fractions that just are numbers. That can make things pretty tricky. Although when we approach problems like this, I always like to start them by using a little trick where we can cancel out our fractions right away, and we can turn our fraction terms into whole numbers, essentially. So the trick that you do in order to cancel out the fractions on either side of an equation, we just have them on our left-hand side, is you look at your two denominators and you determine what is your lowest common denominator of the two. What is the least common multiple of 6 and 2? In other words, you're looking for what is the smallest number that they both could multiply into. And since 2 will multiply into 6, 2 times 3 gives you 6, 6 would be our lowest common multiple, or lowest common denominator. So that is what we are going to multiply by on both sides. So the trick is multiply by the least common multiple. I'm just going to write LCM, which in this case is 6, in order to clear your fractions. Okay. So taking our original problem, I'm going to rewrite that. X plus 7 over 6. I'm going to leave a little space because we're going to be multiplying things in here. 2x minus 8 over 2. I'm going to put our original problem in parentheses for now. Equals negative 4. Okay. I'm going to put that in parentheses there. So there's our original problem. We are coming in and multiplying by 6 on both sides of our equation. Because as long as we do multiply by the same thing on both sides, it's okay. Our equation remains balanced. As long as we do anything that's the same on both sides, it's okay. So we're going to decide to multiply by 6 specifically. But since we have two terms, two fractions on the left-hand side, we have to multiply both fractions by 6. So both terms need to be multiplied by 6 on the left-hand side. On the right-hand side, we only have the one term, the negative 4. So just that is being multiplied by 6 there. So what happens? Well, if you ever multiplying a whole number times a fraction, you can kind of look at diagonally. I mean, if you want to, you can think of this 6 as 6 over 1, but you can reduce fraction multiplication diagonally. The 6's are going to divide each other out, essentially. And then in this next fraction here, we can do the same, kind of think of this as 6 over 1, and if we reduce fractions, 6 over 2 would reduce to 3 over 1, or any fraction over 1, well, you could just make that a whole number then. So in both cases, well, here we're canceling the fraction out. Over here, our fraction turns into a whole number. So we get rid of our fractions in that one step, which is kind of nice. So I'm going to erase what I just did here. Maybe I should write it for you. So we have 6 times x plus 7 over 6 plus 6 times 2x minus 8 over 2 equals, well, we can multiply. Negative 6 times 4 is going to be negative 24. So now coming in and doing as I said, the 6's here will divide each other out, and then 6 divided by the 2 here is going to give you a positive 3. So over here, well, the 6 is divided out, so we just have left the x plus 7 plus, we have a 3 out in front of this parenthesis now. The 2's gone, but we still have the 2x minus 8 up top. So this becomes a 3 outside of that parenthesis, 2x minus 8. In order to move forward here, we have to distribute that 3 before we can do anything else. So 3 times the 2x and the 3 times the minus 8. So let's move that over here. We have x plus 7. 3 times 2x gives us 6x. 3 times negative 8 gives us negative 24 equals negative 24. Combining our like terms, this x plus that 6x gives us 7x. That's 7 plus that minus 24. Do it like this. 7 minus the 24. Let's see, that gives you a minus 17 equals a negative 24 over there. Add 17 to both sides to cancel out the minus 17 here. We get 7x equals, would that give us a negative 7? And then last step, in order to get x by itself, divide by x's coefficient, which is the number 7. Dividing by that 7, we'll cancel out those 7's, giving us x by itself. Negative 7 divided by 7 gives you negative 1. So x equals negative 1 is going to be our final answer there. Okay. So that's pretty tricky, kind of a lot of steps, but it probably makes it easier to cancel out the fractions right away, right off the bat, like we did. Otherwise, I think it even becomes an even trickier problem. So that's the concept of solving equations. The last concept we want to look at is still solving equations, but a little bit easier ones. And once you solve them, classifying them. An equation can be a conditional, an identity, or a contradiction. And you can't really tell necessarily until you solve it completely for x and see what situation you get. Sometimes you can kind of catch it before you do all the work, but if you're not able to catch it, you could always work through the problem like I'm going to here. So we have our first equation here, number 7, 5x minus 15 equals 5x minus 20. Well, if we were solving these the way we were just looking at, we want to get our x terms on the same side. So we'd have to cancel out the 5x on one of the sides, so we just could subtract 5x from here since we have a positive 5x to cancel it. But then that would mean we'd have to subtract 5x from the other side as well, because whatever we do on the one side of the equation, we have to do on the other. That cancels out the 5x's there, but unfortunately over on the right hand side, it's going to cancel out the 5x's as well. So what would be left? Well, we'd bring down the minus 15 equals, bring down the minus 20. That's all we'd have left in that problem. Well, is that true? No. Clearly negative 15 does not equal negative 20. That's a false statement. If you get a false statement, we call this type of equation a contradiction. So that's one of the classifications. Contradiction. What does that mean when you get a contradiction type statement? Well, it means there's no solution. There's no number you could plug in for x so that you'd get 5 times that number minus 15 would equal the same value you would get if you did 5 times that number minus 20. There is no solution for x in a problem like that. We call those contradictions. No solution. Okay. Draw a line here. Our next example, number 8, we have the equation 3x equals 6. Pretty easy one to solve for here. Divide by 3. get x by itself, divide by 3. It cancels out the 3's there and gives us x equals 6 divided by 3 is 2. Well, that's just like the equations we were solving above. We actually got a value, a numerical answer for our variable x. So when you have a situation like that, when you have one solution and it's a clear solution, x equals some number, we call that a conditional. So that's our second kind of classification. It's a conditional equation. I think it's conditional based on, well, 3x equals 6 on the condition that x has to equal 2, because 3 times 2 would give you 6. So it's a conditional statement, meaning it only works on the condition that x equals that specific value. And lastly, number 9, we're going to look at that equation. You have to do a little more work in this one. Start by distributing 2 to the 2x, 2 to the negative 4. That gives us 4x minus 8 equals 4x minus 8. At this point, you can kind of see, well, you have the same thing on both sides. At that point, if you have the exact same thing on both sides of your equation, you can know it is called an identity. That's going to be true no matter what you plug in for x, because you have the exact same thing on both sides. Let's say you didn't catch it there, though, and you decided to try to get your x terms on the same side, so you subtract 4x maybe from that side, which would mean you'd have to subtract 4x from the other side as well. Well, that would cancel out the 4x's on both sides, leaving you with just the negative 8's on the left and the right hand side. So if that was the case, we would have negative 8 equals negative 8, which is obviously a true statement, but that's not the same thing as saying x equals negative 8. That's not saying that x has to be negative 8. When you get two numbers, two constants equal to each other, what that means is that it's well, since it is a true statement, and we call this an identity, but what it really means is that any number you plug in for x is going to work. There's an infinite amount of solutions. There's not only one, like there was in number 8, in problem number 8. There's an infinite amount of solutions. Doesn't matter what you plug in for x. Any number you plug in for x is going to give you the same value on the left-hand side that you get on the right-hand side. So we call that an identity statement. It means there's infinite solutions. And that is all for the review concepts. Section 1.1 in the homework is what this will be good to help you with.